Okay, yes, Wells. So moving on from what we've been learning so far about molecules, we're going to look at the physical properties of molecular substances. Now, first thing, this slide is explaining the difference between intramolecular and intermolecular forces. Intramolecular forces is the covalent bond or the sharing of electrons that are holding the two atoms together. So we have here an example of HCl. The H and the Cl are sharing electrons. That is a strong covalent bond. That's a very strong force holding those two atoms together, not easily broken. Okay, so that's the intra. Intra is like inside, within. So strong forces within the molecule, the covalent bonds. The intermolecular force is the force between neighboring molecules. So the force between Cl and between HCl and HCl, or between whatever the two molecules are. So it's the force between the two molecules, and these forces are weak in most molecular substances, otherwise known as van der Waals forces. We learn more about these next year. But for now, just know that the intramolecular force, the force within the molecule within the molecule holding the atoms together is strong. The intermolecular force between neighboring molecules is weak. Okay, it's the intermolecular forces that we're most interested in this topic. The strength of the intermolecular force will determine the melting point and the boiling point. So if the forces are weak, if there are weak intermolecular forces, then it's easy to separate these molecules into a liquid or gaseous state. Okay, so that means that there's a low melting point or boiling point. So weak intermolecular forces means it's easy to separate the molecules into a liquid or gas state. It doesn't take much energy, and therefore the melting and boiling point is low, because not much heat energy is required to separate the molecules. If the intermolecular forces are strong, then the melting point and boiling point will be higher, because more energy will be required to overcome the intermolecular force and separate the molecules into a liquid or gas state. Okay, so I guess that's what we're saying here. When a substance is heated, energy is used to break the intermolecular forces. Weak intermolecular forces will require less energy to break, and therefore the covalent substances will have relatively low melting point and boiling points, because as we know that the intermolecular forces between molecules are relatively weak. So they don't require much energy, therefore they don't require much energy to break, and therefore the melting point and boiling point is relatively low. Okay, conductivity. For a substance to conduct electricity, two things are required. We have to have charged particles, and those charged particles have to be free to move. Okay, there are some situations where we have charged particles, but they're not free to move. That won't conduct electricity. Or if we don't have charged particles, no conducting of electricity. For example, pure water actually does not conduct electricity, because pure water has no charged particles. It has H2O molecules, but they're not charged, so it does not conduct electricity. Salt water or common tap water will conduct electricity to some extent because it has ions in it. Okay, so what we're saying here is covalent molecules do not contain charged particles. Okay, so covalent molecules are not charged, and therefore they will not conduct electricity and are used as insulators. The molecules are electrically neutral, with electrons that are tightly held in shells or within covalent bonds. So yeah, what we're saying there is that molecules are not charged particles, therefore molecular substances do not conduct electricity, and H2O is an example of that. So covalent molecular substances are classified as insulators, not conducting electricity. Okay, here's a bit of a summary slide. So Molecular substances, the particles are molecules. That's what we're seeing here. Let's say, for instance, this was, I don't know, maybe this is hydrogen gas. Here we've got two hydrogen atoms bonded to each other. This is showing it going from a solid state to a liquid or gas state. Molecules can be polar or non-polar. Non-polar molecules are usually soluble in non-polar solvents, such as cyclohexane. Polar molecules are usually soluble in polar solvents, such as water. The general rule is that like dissolves like. Okay, the forces between the atoms, the intramolecular forces, are strong. That's a strong covalent bond, the sharing of electrons that is holding the two atoms together. But it's not those forces that are being broken when the solid melts or the liquid boils. What is being broken is the weak intermolecular forces, the forces between molecules. So the weak intermolecular forces, or van der Waals forces, are holding the molecules together, and they require only a small amount of energy to be overcome. This means that the substances have low melting and boiling points. Since the weak van der Waals forces allow the molecules to be easily separated, this makes them soft or brittle. That's not as important, but it's easy to break them as solids. Okay, molecular solids are made up of molecules in which the atoms are covalently bonded to each other. They do not contain mobile charged particles. Okay, no charged particles that are free to move. Therefore, molecular substances cannot conduct in the solid or liquid state. Alright, so that's a bit of an overview of molecular substances so far. Okay, you can now do these pages in your SciPad, 70 to 74, or textbook pages 128 to 130. I'm not sure if there's an activity. Actually, let me just have a quick look. 120 to 130. Okay, yes. What you could do is, oh man, it's a long exercise. No, just focus on the notes. Don't worry about doing any of the activities in the textbook. If you've got the SciPad, you could do those pages, but if you've got the textbook, just read over the notes and make sure that you understand them.